a robust routing pattern we generated using finite state machines, especially for A/B test. Little bit talking about me, I'm Tapan. I work as a software developer at Flyfin. It's a US-based product for freelancers, especially. It's like a taxing engine. So yeah, we'll move on. So routing in React apps, especially what we do, like we use React router or routing solution of Next.js, and then all the logic for the navigation, whether it's like be back or forward, lives inside the UI layer only, the screens or the components. And then if there are some logic involved going back or forward, it becomes messy or complex, having back or forward handling all the logic. And then if you want to add some screen in between the flow or remove the screen, or we want to logically navigate the user to some screen. So in that case, it needs refactoring, like taking that handler and adding one more logic for adding one more screen. So it becomes very much complex. And also for A/B tests, if you're using A/B tests with Firebase, it gives us that bucket ID. And depending on that particular bucket ID, there's a difference in the flow. So creating that tree kind of structure at runtime and then handling the whole logic. By logic, I mean there'll be different buckets, right? So it will be like for bucket A, go to this screen, or bucket B, go to this screen. So these are the basic problems we have in React apps. So talking about our flow, it's too much complex if you see. So basic, by the way, this is the X states that I'll be talking about it later. It's the visualizer it provides. So we just have to create the station here, and everything is visualize how the flow will work. There'll be two next buttons, and if I click here, then it will move forward, and then if I previous, then it will go back. So it works like that. So the solution for this is using finite state machines. What is a finite state machine? Let's Google it quickly. So by the definition, it's a mathematical model, which is it's an abstract machine that can be exactly one of a finite number of states at a given time. So a little example, if we check here, this is the locked state. If we push, it will go back and then it will unlock. So, or we can say like temperature, it can be hot or it can be cold. So there'll be finite states, and it will be one of the finite states at a particular time. So there's a good library called XState for React, which does all the heavy lifting for us. And there's a special this provides all the basic things like create machines, and then for creating different configs. And there's a different library for React specially, which provides us hooks to like this use machine or create machine. This is from XState only, but use machine hook this XState React provides us. So talking about XState Glossary. So there are states. States can be atomic, compound, or final. By atomic, I mean that state will be a streamlined single linear state. And then by compound, I mean there can be nested states inside a particular state. And by final, I mean there will be a node which will be final. After reaching the final state, all the actions will be just ignored. By action, I mean there are pure functions which we call just like we dispatch actions in Redux. It's the same. We call the action, and state machine will do whatever is configured inside it. By guard, guards are basically functions which provides a boolean value, true or false. So for a particular screen, there can be multiple possible screens, and there'll be a logic. whether to move to that particular screen or not. Guards provide us that. So yeah, let's move on to the next slide. So we'll be giving an example to migrate a normal React app using CRA to XState. So I've created this small flow, which includes one welcome screen, and then there's an onboarding question. So there's also a checkbox. If it is true, like it is checked, then the user will go to this screen. And if it is not, then user will go to question two and then move on to the screen. And then like this is a small example of our Flatten app. It's like the user wants to connect these statements, or he can also share the statements over email. So if you want to connect your statements, you have to do sign up because it will require user authentication. And then directly you can connect your bank. So in sign up and this connect your bank logic, there can be two possible things. There can be an error or there can be a success. If it is success, then it will move to the other screen, and if on the connect bank logic success, it will move to this success screen. And then there's another screen which includes you will receive an email or reply with the necessary details. Then just click on the request email and it will go to success. So I've created this small project. It's bare minimum React project, and it contains these screens. All of the screens are here, and we'll be adding XState on this particular project. So I'll just quickly change the branch and walk through what I did, and I'll also run a yarn. So we have just added this system folder. It includes experiments. So this is the base experiment. Which is like it has an ID, which is example. There'll be an initial screen, which is home. By the way, all these screens to route map is here. So if you have this key home, it will be routing to the slash route. And then we have different screens configured here. And these are the handlers. I'm clicking on next, this is the next action. It will be going to onboarding question one. And in the same way, we have configured all of these here and also the previous one. Also, this is will be taking up in the next branch. So there are two targets for the screen. It can be onboarding question 1A or onboarding question 2. So as in Figma, there can be two possible targets. So let me just quickly change. Okay, also there are some hand this will be the file which will include all the guards. And then main thing is this machine subscriber. It will subscribe to the machine, and if there's any change, it will just take the user to router. It will just do router.push and then to the next screen. I'll be just quickly walking through how this is being done right now. So see, the whole logic is living here. I'm doing should so this is just a key. If it is checked, then it should be true. And if it's true, it will take the user to question 1A. And if not, simply to the question 2. But the main issue comes when there are more logics and maybe the A/B test comes in the picture. It will become pretty much complex. And also for the back handler. So right now, I'm just doing history.back. But what if I want to take the user somewhere else? Let's say I'm coming from 1A. I want to go to 1, not 1A. So for better explanation, I'll do that here. So let's say I'm on question 1 and I navigated to 1A and then to 2 so I missed this out here. Now I wanted to move back directly to question 1. So in this scenario, history.back will not work. We have to manually handle that logic here and take the user to the specific screen. So for that, For that, these previous keys will help. So we'll uh, change the branch to a different one. So I've just in this branch I've just refactored in this way that I've added all the back handlers in the screen itself. So previously it was being handled from the main screen. It used to live here, the back handler, this one. So it's just the small thing. Okay, so how to change the whole thing? If I just move to the previous branch, and right now I'm on, let's say, the home screen. I'm doing router.push here. So I just have to use the machine subscriber, and it will give us two things, basically three things.
Tap,
The
Tapan, can you zoom
Yeah,
in the screen? We can't see the code.
okay, cool. Is it better now?
A little bit more.
Okay, how about now? I'll
Yes,
close
yes,
this one
it's
also.
good. It's
Cool.
good.
Cool. So this customer will just give us three things: the current level state, the current screen of the machine, and then there's this basically this is a function which takes in the params and other things, and this one is service. So we just want to use send here. Uh, so what you do, what we'll just restructure send from use machine subscriber, and then we'll just simply do send. And for the next like keys, I've just created this constant which includes everything. We just have to do next, and we don't have to actually use the router. And if I just show you, it's basically here. And now when I go next, it will take me to question one. And so we'll just check out the branch where it is already configured everything. Okay. So now if you see these things are handled, and now if I go to the question one, here's uh, these are the actions that we are sending to the machine. But one thing is not yet done, which is the payload. So we want to handle that logic, right? And we want to handle it by XState only. So we have to send the payload. So the payload can be this one should go to 1A or not, and then the machine will receive it in the target. So if I just quickly change the branch, we are sending the payload from here, should go to 1A or not, and then the condition. So this condition is, as I talked, it's a function which returns Boolean. So it receives the event. Event will contain the payload, and it will just returning. And if this condition is true, this target will be resolved. If not, the machine iteration will move to the next target. And since there's no condition here, it will move to this screen. You must have seen these new things have added. These are basically actions which run on each target. And this is basically setting the this key to the XState context. So it's also includes one context where we can save data and reuse later. So I've just manipulated the this key. It's now true if the checkbox is marked. And then in the back handlers, we can just like next, we have back handler also, which includes to target. And similarly, if this condition is true, then it will go to 1A. If not, it will go to the first question. So now how it works, we'll do a reload and then see if I click on this check mark, it will take the user to 1A. And if not, it will take the user to question A. So that's how. it works. Now the question comes, how is it helping us in the A/B testing? So right now, adding and removing screens, it's pretty easy. I just have to take the config and simply I can just add one more screen. Let's say I'm adding this screen and I just map it to the next function and change it the next of this flow and also similarly change the previous handler. And yeah, we just have to add the screen in the code and it's already configured. So it's that simple. So the thing is, adding this is a little bit painful if you are having a big code base. You have to check the whole flow, visualize it, and then create the configs, write the conditions, and also it's a bit hectic at once. But once it's up, it's very seamless to change. So we'll be talking about how we can simply add another config. So we'll just remove it. And then I can just simply add one more experiment. I can call it maybe experiment B. And then just I'll just copy this. And after that, we'll maybe change the initial route, maybe from home to onboarding question one. And I'll just get rid of this home. Uh, And then what I'll do, I'll just remove the backender because since it's the initial screen, there will be no back button here. We'll change the name of the machine. Similarly here, and then I'll just go to the wrapper. So wrapper is basically which tells us which machine to use. So we can have it in a better way. We can just take the initial route of the current machine here. No. So we cannot we can do write it in a better way. We cannot hard code this because it will depend. But yeah, we can. So here we can just change the machine. So if you're having this, okay. So wherever it is, the base experiment, we can simply change it. So here we have all the experiments. We have to maintain it like in order to know which all experiments we are having. And based on the bucket ID, which is Firebase is giving us, we can change the particular experiment. So right now we have this new experiment, which is experiment B. And then we in this file, which gives us machines based on keys, we can just add one more switch case, which is for this one, the experiment B, and then we can just import it. And now what we have to do, we have to change the current experiment. So right now, this use effect is setting the current experiment. So it's just mocking it. In real life, we'll be getting it from some API call or the Firebase config that this is being changed and load another config based on this particular bucket ID. So we'll be, let's just change it. So this was for base experiment. We'll add it from base to experiment B. And then maybe let's make some more changes in order to feel like get the real feel how is it working. Maybe I want to give it a negation. If it is false, if it is false, then go to 1A. Otherwise, go to screen onboarding question 2. So let's see how it works. It might fail. Uh, okay, so the main screen will be this one. So whenever I reload, the initial screen will be one which is configured. And now if I'm checking it, so ideally it should go to the onboarding question to screen, and it goes. So it means that it's working fine. But okay, I think yeah, that's the basic bare minimum configuration. There are some problems also. We'll quickly want to talk about them. If we are using Redux store, we are storing this key here in the context. In that way, there'll be two sources of truth. This condition will be stored here also and in the Redux store also. So in order to solve it, we can just use selectors and just get that key and send it every time here. And we don't have to use actions or context at all. But one thing is also there, if we don't want to have any logic in the screens, we just want to have UI. We cannot rely on these conditions being the logics being sent from the UI. So we can have pure JavaScript functions and we can just use it like should should go to A or not, and then it will return that boolean and tell the machine to go to that particular screen or not. So yeah, I think that's mostly